Hey guys, this is Joel, and you're watching the day three of me learning machine learning using TensorFlow. So today we will be covering the topic of RNN. So yeah, let's get into the topic. So yeah, and let me explain the RNN in a simpler terms to you guys. So yeah, so for example, I'm on writing text. This is app. Oh, right. Sorry if I have grammatical errors, but anyway. Uh, Now, how, like, in actually the RNN, which stands for Recurrent Neural Network, is generally used for natural language processing. So, the natural language processing, which means in general, is like how the computer processes the textual data that is in human format and they understand it and they predict or analyze or give a statistical analysis of an input. So yeah, so that's it. That's what NLP is. And here, let me explain the RNN. So for instance, we're gonna this is tokens one, two, and this is three, this is four, and this is five. So how this model works is that first there is this function on which we will be sending the token this, and we'll be sending this, and it will be training. And after that there will be another function in which you will be giving the second token. So you will be giving this, all right, and moreover you will be giving the output of this first model, right? So it goes on like this, until it's fine. So that's how it works. So I think you might have a pretty good understanding of how it works. And after this thing, you might need to learn about encoding or not encoding, the encoding done over here, and LSTM. So I'll just give you a small idea of how LSTM works. So the LSTM is like long short term memory. So in general, RNN, what happens is that you won't be, having the memory of what happened here after, moving on from this phase, right? So in long short memory, you will be having this access also. So that's the primary difference between these two. So you'll be having access of an already happened function or an event. So yeah, let's begin with it. So, uh, so actually I already done this code in VS Code, but I thought I'll just make a quick video, you know, because ours is quite short, so I won't be explaining with some example, and next I will be covering reinforced learning, true learning. So I'm a little bit excited because it's new for me too. I don't know. I never done any work on reinforced. Other than that, I've worked many aspects, but not yet. Anyway, now what we're gonna do is that, so for example, what I want to say is that I'll show you two input. I thought the movie was going to be bad, but it was actually amazing. I thought the movie was going to be amazing, but it was actually bad. But two different things have different meanings, right? But how does the computer understand what it means? So the machine would understand. So we're learning how it's gonna understand it, right? So let's begin. So it's actually about back and forth, encoding and assembling, both things, embedding and encoding. And yeah, this is the model which I told, HTA. So the input of this, and then H1, H2 will be used to, the output will be used along with the second input to create the model. So it goes on, right? And the LSTM. Okay. Let's start with the movie review data. So now we're going to use NLP to do an sentiment analysis on movie reviews from IMDb. Right? I know I am thinking, so yeah, I'm from IMDb effect. So what I'm going to do is I'm just going to go. So as usual, I'm not going to explain every part of the code because it is self-explanatory, and like you don't really need to know all the syntax as well because it's really impossible to know get all the syntaxes. You just have to know how this one syntax work, how this one function work, and you have to have the right mindset to apply it. So that's what it matters. So and I'll go just a short summary of how things happen over here. So that we start. So yeah, this thing is for the Google Colab. So if you're not using Google Colab, you don't need to use this line. So it's called TensorFlow. And now we're just importing the libraries. So IMDb, Sequence, Keras, TensorFlow, and we are like initializing some variables like vocabulary size, which you will learn later. So yeah, we have actually split the data and we have run this block of code and the data has been downloaded. Right. So let's check one example of data. So I'll do one place. So it has these many values. Actually, each words or characters will be changed to an value. That's how it works. Now, what I'm going to do is that, so it is an already existing data. So what I'm going to do is that I'm going to pre-process that data because we have to have an uniformity no matter what machine learning. Like, if you're on machine learning, deep learning, anything, you have to have an uniformity of the input data. So what we are going to do is that we are going to get it between 0 to 250, right? If I mean, like, if there's a review that says like in thousands of words, we're gonna use the only first 50 words. If it is less than 250, what we're gonna do is that we're gonna add zeros or zeros to the ending. So it's like 150. That is a review with just 150 words, right? And remaining 100 words are to be needed. So what we're going to do is we're going to add zeros, just to fulfill the data. All right. So, and for that, the TensorFlow actually gives an amazing function. So if you just going to use this train data max, it's going to train data maximum. So you're giving the maximum length. So for it to trim or extend, right? So yeah, we did that. And now we actually created the model. So first, what we're going to do is that, so as you already know, model.tf current sequence is making a model and there are layers. So first we're gonna add the embedding layer. So in the embedding layer, we'll be having the vocabulary size. So that's the size which we have given over here. Just hold on a second. Yeah, 88584. So that much vocabulary we're gonna use, and then we're gonna make it to 32 packs, and then yeah, LSTM 32. And so the output mode is one only. So let us train the model. The embedding is the how it goes. Okay, now let's talk about embedding, right? So let me just create a new thing. So what embedding does is that let me show you a graph of like now what happens that the embedding just stores the value. I mean, like if you see a vocabulary, there may be lots and lots of words. For example, the first element in an vocabulary list is good, right? G-O-O-D. And the 100th element would also mean the same, like great or something which means the same. But how does the computer know that it is same, right? So for that, they have created a vector-based thing, so which means all the good things will be lying one place. Like for example, yeah, over here is good and over here is great. So the degree between them is less. But if you're talking about something which is bad, right? So it will be in another plane. So the difference between the angle is this. So which makes the computer understand that it is a different word from the already existing word. So that's works. Okay. And now we are seeing the summary. So embedding business parameters and then 32 business parameters and then again business parameters. So then what we want to do is we are going to train the model. So before training, we have to compile the model, right? So for that, we are using an optimizer called RMS prop. It is also an optimizer. So yeah, and now I want to put the model. So it takes some time to prepare the model. So let's just go up to it and then build this. So actually, NLP is an interesting topic. You could always learn a lot. And and I might have skipped the what do you call it, the theoretical part. I mean, I was a bit focusing on the coding which I wanted to learn. So yeah, that's the reason. So yeah, I might in the future make a video about the theoretical part, explaining each and every bit. But right now I'm just doing this, and yeah, I think it's going to take some time. So what I want to do is that it's not ending. Okay, let's just go. Now what we're gonna do is we're gonna evaluate. So it is the input trained model results. So let's just make some prediction with the already existing images, right? So I mean, we have made the model, right? So what we're gonna do is that this is actually an get index word is getting all the index words, all the vocabulary words from the IMDb data set. So you don't need to add those words. So we're just getting the index of all these words. And now what we want to do is that always during NLP, you have to encode and decode. That's how it works. Because you have to encode into something which will be used to, do the functions, and then you will be decoded back, which will be pursued by us, right? So in that, with that keeping in mind, we're going to encode the text, the input text. So here, the input text is that movie was just amazing, so amazing, right? So we want to encode it. So what happens here is we're gonna make it text to word sequence. So we're gonna like tokenize it. So like this is Joel. So this is Joel. So we're gonna separate it in that way. Now we're gonna make a list of those words, right? So that's how it works. So we want to make a list of words like word index of word. If word in word index else zero, it's something. If it doesn't exist in that vocabulary, it's gonna be zero. So that's what it explains. So we're encoding it. So yeah, on this phone I'm on there. So yeah, and then we are gonna decode. So as I already told you, have to encode and then decode. So what I want to do is that, so I want to reverse the word index. So for that, we actually make a key value back. So get word index, right? So we actually got the word index. So, I mean, we got the key from an value. So we are going to convert it into value from key, get the characters or the words from the numerical value. So with that, I'm going to decode the integers. So here's the function, pat zero text, in this we'll be getting characters or the words from the number. So that's how it works. Now, with after the encoding and decoding part, you can just directly go to the so actually with this the video ends. So let's just wait for the model to train. Yeah, we are successfully trained. Now we can see the results. So we are actually evaluating, I think. So this is so it means the input. So we are the input is 0.4% negative and 0.8% true. So that's how it works. So it is more prone to be an positive thing. Mm-hmm. Oh, so what we did is we have encoded and decoded and we are going to predict. So for predict our text, we're going to encode the text and then this is actually, we're creating a list, right? Using NumPy array, we're going to create a list which contains 25 spaces, but in that 25 spaces, we're going to have zeros in every index so that we can replace the value later on, right? So for that, we're going to use that and thread of zero. The first one will be the encoded text, and then we'll be predicting that, uh, what you want to predict. So with this, we can predict the sentiment analysis of a movie. So this given custom input. So that movie was really loved it, and it would be advanced, blah blah blah. So after running through the code, it happens to be 0.86, which is it is an positive remark towards the movie. But whereas it's the movie was really sucked at this review, it seems that it's more negative. So yeah, guys, like we have successfully completed the NLP by like we did a sentiment analysis on a movie review, and with that we actually got succeeded in predicting the movie review was good or bad. So yeah, this is the result. So thank you guys. I think you might have loved this video. If not, you can just suggest me what I should do. Maybe talk a little bit slower. Actually, I was trying to talk a little bit slower because all my videos. I also think I might have talked a bit faster in this video, but I feel like I should talk a bit slower so that everyone could understand without pausing it or making it slow video. So yeah, I'm kind of improving. So improvement is the key. So yeah, guys, thank you. Have a nice day. And